Hello, my name is Charlotte Whitcomb. I am an Oxbridge Mind tutor, and today I'll be taking you through tutorial 5 on the PA2 Oxbridge course on circuits. So unless you've already been through other tutorials, I'm going to go through a quick recap on what this lesson plan is. So first we're going to recap topic content, then we're going to work through past paper questions and discuss strategies and approaches. And then we're going to identify common pitfalls and plan courses of action to avoid them. So this is a quick breakdown on the topics we're going to cover in the tutorial today. So we're going to cover voltage, current and resistance, which involves charge, time, energy, power, also some quantum energy levels. Then we're going to have a look at circuit analysis, which involves components and IV characteristics, combining resistors and capacitors. We're going to look at electromagnetic induction, primarily transformers, some capacitance involving charging and discharging and the effect of area and distance between plates, and the photoelectric effect, so photon and photoelectric energy and the work function. So first we're going to cover Kirchhoff's laws, and the first law is the sum of the current into a point is equal to the sum of the current out of it. And here you can see sigma I in must be naught. Second Kirchhoff's law is that the sum of the potential differences around a closed loop is equal to the EMF across the loop. And this is shown by the sigmas here, where the epsilon represents the potential differences. Combining resistors. So the rule of combining resistors in series is that you just sum them. Combining resistors in parallel. Remember, it's 1 over RT is 1 over R1 plus 1 over R2. It's a very simple error to make, to forget to take the reciprocal to find. It's a very easy mistake to make, to take the reciprocal of the other two resistors, add them together, and forget to take the reciprocal again to find RT. Capacitance, this is going to be a new subject for a majority of you, unless you've read ahead in your A-level syllabus. Typically, a capacitor is basically two metal conducted plates connected in a circuit with a positive potential difference on one side and a negative potential difference on the other. Now, the charge stored between these two electrically charged plates is equal to the capacitance of the capacitor times the potential difference across it. So some of you have not come across capacitors before, and in essence what they are two metal plates or plates made out of conductors, one positively charged, one negatively charged, with a potential difference across them. And what they do when they're charged is set up a uniform electric field in between the two plates, and this allows capacitors to store charge. Now, the charge stored by a capacitor is governed by the equation here, and is equal to the capacitance of the capacitor times by the potential difference across the plates. And you can find the capacitance, and it is determined by a number of physical quantities of the plates, and one is the electrical permittivity, where E0 is one of these quantities is the electrical permittivity. In this case, it's epsilon naught, which is the permittivity of free space. This could also be multiplied by epsilon r, which is relative permittivity, or if there's, for instance, a dielectric within the two plates. This is then multiplied by the area of the plates and over the distance between the plates. Notice that the area is just the area of a singular plate, or just the cross-sectional area of the capacitor itself. Now moving on to transformers. These are cores of wire wrapped around an iron core designed. Moving on to transformers, most of this will be familiar to you who have done electricity before. Moving on to transformers. Most of you are familiar with these, having done GCSE And these are coils of wire wrapped around an iron core designed to use electromagnetic induction to transfer power. The potential difference is proportional to the number of turns in the coil, and you know the governing equation being V1 over V2 is equal to N1 over N2. And remember that an ideal transformer has no power loss within the coils and within the iron core itself, because in reality you would have resistance in many of the coils, which would add to produce heating. You'd lose power through this way, and you can create eddy currents within the iron core itself, and that would also produce heat and cause power loss. So remember, when you're asking PAT questions, to revise the assumptions you make about these circuits. Most of the time it's about power loss, and the presence of resistance in certain areas. So just remember to write down these points when it's needed. Also, beyond memorization of equations, the PAT requires understanding of quantities and when different equations are appropriate. Especially in circuits, there are many different equations you can pull from if you need to find certain quantities. So in topics such as circuits, the quantities are tiny, they're microscopic, and analogies are a useful tool to help understand the behavior of these quantities. So for instance, the relationships between current, area, length, and resistance is analogous to the flow of water through a pipe. Examine the assumptions behind any equations used. For example, Ohm's law is one of the most useful equations in circuit questions, but this only applies to ohmic resistors with certain limits of temperature. And also, what is the relationship between power and resistance? You may have found that there are many different forms where you can use P equals IV, V squared over R, or I squared R. And depending on which equation can be used, the answer could be different, and this is very important in your PAT. So you need to examine the assumptions made in this case. So for instance, P equals IV applies to all systems. However, here both V and I can be functions of R. P equals V squared over R and I squared R, you must assume Ohm's law applies, because that's how you get those equations. You just resubstitute Ohm's law into P equals IV. Now, P being proportional to 1 over R applies when the voltage itself is constant. The current must change to keep the voltage constant, because from V equals IR, we know that's the case. If P is proportional to R, this applies when the current is constant. The voltage must change to keep the current constant. And if the current and the voltage are both kept constant, changing the resistance will not affect the power. So here is a past PAT question from 2020, and this is a quick multiple choice question where we apply resistor rules and Ohm's law as well. So here we're just asked which ammeter gives the highest reading, labelled in this diagram. So first things first, we find the combined resistances of the loops, and then from intuition we can see that the lower the overall resistance of a loop, the more the current that will flow through it, and then the higher the ammeter reading. So if we combine the resistors in the first loop, so for loop A, we combine R in series with R and 2R in parallel, which would be R times 2R over R plus 2R. And this is equal to R plus 2R over 3, which equals to 5/3 R. Now, if we do loop D, this is just 2 in series, which is R plus R over 3, which is equal to 4 over 3R. Now, if we can see for loop E, it's just 1.4 R. Now, from Kirchhoff's first law, we know that IA is equal to IB plus IC. So therefore IB is less than IA and IC is less than IA. So therefore they are definitely not going to be showing the highest current. So therefore from this we can see that IA is more than IE, which is more than ID, due to the fact that ID has the lowest resistance of a loop. So therefore, we know that D is going to have the lowest resistance and therefore the highest current. So just a general tip, circuit analysis is one of the most fiendish topics in the PAT. To approach these questions, just keep the following in mind. Redraw the circuit diagram to look more approachable, keep the nodes, i.e. the connection points, the same, and bend the wires to a familiar circuit structure. And also take the question step by step. So find combinations of devices to form equivalent circuits until the entire circuit is reduced to simpler equations. So for instance, combine resistors, which can be easily combined, or rearrange resistors so you can combine them, as long as you remember to make sure those connection points are the same. So now we're going to choose and have a look. So now we're going to have a look at another past paper question. This is based on capacitors, which again, you'll be slightly unfamiliar with unless you've read ahead in your syllabus. Now we're going to consider the network of capacitors shown below, and all have the same capacitance C, which makes life easier. What's good here is they actually give you the laws here, because they don't assume that you've read ahead, though it is very useful and I do recommend doing so. So here, two capacitors in series combine their capacitance the same way that two resistors in parallel combine their resistance, and two capacitors in parallel combine their capacitance in the same way that two resistors in series combine their resistance. And they ask you to find the total capacitance. And they ask you to find the total capacitance, C total, between the points A and B. So here they're just testing to see how well you apply new concepts to unfamiliar situations. So we're going to run through this, and it's good to take it row by row and then combine all the rows together at the end. So we can see in row, we have row 1, row 2, and row 3. So in row 1, we have two capacitors in series, and we know they're going to combine their capacitance like resistors in parallel. So C1 is equal to C times C over 2C, which equals C over 2. Now, if we apply this to C2, we know that So if we apply this with loop 2, we know these two capacitors are going to combine like they're in series. So this is going to equal to 2C. And we're going to have to combine that with this in equivalent of parallel. So it's going to be 2C times C over 3C, which equals 2C over 3. And this final loop, C3, is going to simply be C plus C plus C, because all these capacitors are in parallel and they therefore combine like resistors in series. So this C3 is just going to be 3C. Now if you combine all these together, so C over 2 plus 2C over 3 plus 3C, we get 25 over 6C, which is the correct answer. Now, just a little advice on this. Capacitors and capacitance are topics which have only recently introduced to most students taking the PAT. But questions asked in the PAT will not rely on complicated equations, but focus on the understanding on concept of capacitors. So prepare for questions about capacitance by learning the role of capacitors as devices to store charge and electrical potential energy. As I said earlier, it's about those two metal plates setting up a uniform electric field between them, and this is what stores electrical potential energy. Some common pitfalls when approaching these sort of questions: complicated circuit analysis, if, for example, you are unsure of how to approach a complicated circuit diagram, just take the question step by step, practice circuit analysis to become familiar with complicated circuits, and just remember, simplify resistors, simplify capacitors in your head, and just practice applying these rules as much as you can, because again, it's about that literacy when you're approaching questions like this and cutting down that time you spend. Another thing you could find hard about this is misunderstanding capacitors. For instance, incorrectly answering questions on the properties or behavior of capacitors. I just spent some time understanding the concepts behind capacitors, used knowledge from the electric fields module as well to place capacitors as energy storage devices. So remember how you can apply uniform electric fields and the properties behind those, and you should be fine. Also remember, write down all of the characteristic equations associated with capacitors, like resistors and like other electrical components like diodes. Just remember what their profiles look like, their IV profiles look like, what their governing equations are, because you could be asked any one of these questions, and also just explaining the basic concepts behind them too. So definitely read second year material, for instance. And that completes tutorial 5. And I hope this was useful, and I look forward to explaining some other concepts to you in other tutorials as well.